Hey, how's it going, Like? It's me. You're back again for another exciting installment of the Pro Vlog. In this episode, I wasn't sure how I was going to put this part across because I'm not going to do a engine build tutorial because I don't think I'm really the technical authority for doing that. But what I think we really need to talk about is whether you should run an RB style engine in your drift build. If you like what you're seeing, hit the like button. Don't be shy, hit that subscribe button and check us out on all the social medias at Pro307. This is the RB26 short block that I run in my competition drift car, or I've been running in my competition drift car up to now. These are getting old, these engines, a bit like me, and I thought I just would go and give you a no bullshit kind of what to look out for if you're planning to get into building a RB26 engine for a competition car. I have been using this for about maybe 10 years. For all the time I've had out on track, I've had more problems. I've destroyed cylinder heads, I've destroyed crankshafts, and it's mainly down to my own stupidity really and not knowing enough. But at the end of that, all my research and all my time spent working in the engine, I think I've got a better idea what we can do to make this engine work for me. The question is it going to work for you? So what I'm going to cover in this video is I'm going to speak about the blocks, I'm going to speak about the cylinder heads, I'm going to speak about the infamous RB oiling problem. I'm also going to speak about the drive on the crankshaft and different oil pumps. Through that I'll give you a bit of an insight into putting the engine together, checking oil clearances and fitting the shells and that. Also I'm going to show you installing a Spline drive operated oil pump to the engine. So let's get started with the RB block itself. Now this is an old block and these have been in the road for a while. They've been through multiple heat cycles. Majority of RBs in some time in their life have been overheated in some way, and unfortunately the blocks get stress cracks. This block actually has got stress cracks in it between the coolant jacket, the coolant port and the stud ports. Now this one hasn't given me any bother with leaking, but yeah, it's a bit of a gamble. If I had a bit more money at my disposal, or maybe we would have been able to do something and change the block. But for getting me back and going in competition, this is going to have to do the job. The cracks are real hairline fractures. Now what you would have to do is, if you were getting one of these blocks machined, before you spend all the money, get them to crack test it and inspect the thickness of the cylinders to make sure you've got plenty of meat and you've got a good block. Now, I don't know how many of these blocks are cracked. I've got a feeling that you'd be really surprised to know there's a lot of blocks that are out running that have got these hairline cracks in between the bolt ports. But we're going to put the head on this and we're going to run this and we're going to try and make a bit of power out of it, so stay tuned to later on in the series where we can actually see if this is going to work. So the blocks, old blocks, they can be porous, they can be cracked, and it's important if you're building a really big, like a 1,000–1,500 horsepower engine, to get them checked. I'm not going to be running that level of power. I'll be pushing if I make 600 horsepower out of this engine, and the main focus is to try and make it more drivable rather than taking mega power figures. Right, so first thing, cracks in the block. Big deal, not a big deal, not sure, we'll find out later on in the series. But one of the main issues that you'll hear everybody speaking about with RB series engines, whether it's an RB25, RB30 or an RB26, is the over-oiling of the cylinder head. Now, let me explain this. The oil pump driven off the front of the engine circulates oil around about the system. There is a single oil port in an RB26. There is 2 oil ports in an RB25. And there's a factory orifice, for example in my engine, of 2 mil in the block that controls the amount of oil going into the cylinder head. When the engine's making 300 horsepower at the factory, it's not a problem and it's kept at its 7,000 rev limit and it just uses a street car. This is not an issue. but when you're running higher revs, when you're pulling more power, when you're driving on track or doing drag racing, the oil pump tends to put too much oil into the cylinder head, which drains the sump. You lose oil pressure to the lowest part of the engine, which is the big end shells, or the big end of the conrods, and yeah, you spin a shell, or you do damage due to lack of oil. You'll pull a lot of RBs apart and find that the shells are starting to rub through into the copper, and this is just through wear and through oiling issues. So the question is, how do you counter that? Well, there's lots of different ways of doing it. If you're building a street car, there's recommendations for what size of oil orifice to fit into this port, and for an RB25 you actually blank off the secondary port. I've been running a 1.5mm tow-my restrictor, which has worked up to now, but in this build we're going to be running a bigger flow, bigger pressure oil pump. So the recommendations from lots of different places are a 1mm oil restrictor. Now in this block, if you're doing a full rebuild, I'd recommend you drill and tap and pull the 2mm orifice out first of the block, then clean the block entirely when it's stripped down, clean out all the oil orifices just to make sure there's not any dirt or debris left in them if you're doing a new build. So to get the 1.5mm restrictor out that I had before, I ended up drilling it, tapping it, and using a 4mm bolt and jacking it out of the block, which worked really well. And then you get to tamp the 1.1mm restrictor in. Now, from what I've been looking into, the main sizes of oil restrictors are a 1.1, a 1.3 and a 1.5, and these are all different size for different applications, so always double check. For example, Nitto do 3, Supertech do Superforma, which is the company that I've used, to do 3 different types, so always make sure that you're using the right orifice for the right application. Drift car, high RPM, big pump is a 1.1 restrictor, so that's what I've used. So it's a block, RB26 oiling problem, head drain, which is we'll get to in the second part of this video, is exactly as it says. It's a port on the top of the head that allows oil to drain out back into the sump. Do I think it's the only way you can fix the oiling problem? To be honest, I think it's a bit of a gimmick. Am I not going to run a head drain? Absolutely not. I still run a head drain. We're going to be showing you the PRP head drain being fitted in the next episode, and personally I think that's the best one that's available at the moment on the market. So we've cleared up that the engine's got oiling issues from factory, we've cleared up that the block cracks when it's old. Like me, cylinder heads are usually really good. They've got solid lifters from the factory. They are probably, other than the fact they don't have variable valve timing, a very good flowing cylinder head, although you're better to get a bit of port and polish done to them. My cylinder head you're going to be seeing fit to this engine has not got anything particularly fancy done to it other than cams and a port and polish. I did get the option to oversize valves, but at the time my budget couldn't stretch to that. I feel like I'm really playing down the RB26 in this video a little bit. It's a really good engine, but there are issues. The cylinder head, the castings can be porous and you can get a leak in the actual casting in the cylinder head. And my cylinder heads had a mod done that it diverts the water gallery in the head around the back. It's all drilled and tapped, and I can't really get into it much more than that because I'd sent it away and it got done. But if you find that you're having problems and you think it's head gasket problems, there's water in the oil, there is a chance that the standard cylinder head is porous and you've got a leak internally there. So the last thing I'm going to cover, speaking about the RB26 engines, to help you decide whether you should run one in your build, think about the oil pump that you're going to be running and the drive and the end of the crankshaft. Now, if you've done your research into RBs, you'll know that the early engines had a really short drive that wasn't even the full length of the oil pump, and they're really bad for breaking the oil gear inside the oil pump. But there's been advances even since then, the latest being spline drive kits or sine drive kits from Nitto. Now I'm going to be running a spline drive in this. Crankshaft went away to DY Engine Services, and they did a cracking job of machining the crankshaft. They polished all the journals, and they shrink fitted the spline drive, and it just means you have to rebuild the pump with the spline drive inserts. I think we should have a look at the assembly process of this block. Let's have a look and see what happened with that. So other than the obvious cleaning of the block and painting it just so it looks nice and fresh, the entire block had to be scrubbed top to bottom, all the oil squirters removed and cleaned thoroughly, then just a basic inspection of the engine. The crankshaft was sent away to get balanced by DY Engine Services. Also, they fitted the spline drive onto the end of the crank. The conrods were balanced by DY Engine Services, and I balanced the pistons and the wrist pins myself. If you're thinking about going down this path of building an engine, you have to remember that the balancing of the components doesn't necessarily in itself add power, but it's more adding to the reliability of the engine. Engine that runs smoother, less vibration, in theory works better. It's very important that you get your oil clearances checked and your oil clearances right before your final assembly. I made mistakes in the past, and I made a lot of blunders with this engine with just throwing things together. You need to get yourself a good micrometer, good bore gauges, and a copy of the manual, the service manual. It's very good, the Nissan service manual. Right, I'm going to stop here before I torque these big end bolts. A few things I want to talk about here is the reason I went for ARP fasteners is purely because I'm doing this level of build. I thought I would upgrade to better fasteners for the girdle, coming away from the standard bolts. Now these bolts are going to help prevent the girdle floating under load when it's under boost. A few things to check here before you torque down is make sure that the girdle is lined up properly. It's easy to get this pushed back the way, and it gives you an uneven, it's easy for this girdle to be pushed back the way, and there's an uneven force on the thrust washer and it can wear it uneven because it's like a half moon. The best way to go about this is torque it down, then check your end float on your crank nose with a DTI. When you're oversizing the cylinders, in my instance these are 86.5 bore, which is half mil oversized. If you're going to be oversizing, you need a torque plate to get the correct form of the cylinder head to the block for machining and for honing. Piston rings should be checked in the bore with feeler gauge to make sure you got the right oil clearance. If you don't get the right oil clearance, it's either going to have really bad blow-by, or worse, if it's too tight, when the pistons expand under operation, it could effectively be too tight in the cylinder and damage the cylinder walls.
When's the Stone Age? A song about something will never be.
Whoever you're dealing with, if you're dealing with a machine shop or a company that supplies your parts for your RBs, always check with them what recommended oil gaps for your application. This is a race application, so the gaps are quite big. And I did have an issue with this engine last year that it wasn't breathing very well. The RB should breathe a little. They should put a little bit of vapour and oil into the catch can, even when they're, you know, quite new, and mine just wasn't doing that. So I believe this engine was built too tight last time. These have to be spotlessly clean, the decks of the block and the cylinder head, before matching them with the metal head gasket. Easy as that. Right, let's get this episode wrapped up. Should you run an RB style engine in your drift build, whether that be RB20, RB25 and RB26? Now, we went over some of the shortfalls with the RB engine for running in a drift build, like the oiling issues, the block cracking, the cylinder head being porous, and little things like that that's going to cause you like extra cost in your build that you didn't expect to have to deal with. Now, I'm not saying that everybody's going to have this experience. Some people maybe run an RB all their life and not have a problem. Depends how much power you want to pull out the engine. Any engine you try and pull more power out of, you're going to have potential issues with. And you're trying to pull like 800, 900 horsepower out of a motor, you are at kind of the limit of what it's capable of, and there's more potential for problems, failures. And even some of the best built engines by some of the best engine builders still fail catastrophically. Filling you with confidence there for building your motor. The engine struggles without variable valve timing. If you watch some of Adam LZ's videos about his RB R32 build, I think, he compares without variable valve timing, and it has a big difference in the mid-range to your power and torque figure without variable valve timing. Now, a company that I often deal with, RB Motorsport in the UK, do offer a VCAM kit for the RB engine. Of course, you can go as far as getting the HKS kit VCAM. That gives you your variable valve time and intake. And yeah, that would probably make a big benefit to the engine, especially with spooling up that big turbo that you're going to be running to make all the boosts. And unfortunately, just the price of these motors nowadays is getting extortion. The JZ platform, believe it or not, is a lot cheaper to build. There's a lot less you have to put into them to build a good motor. I was speaking to the lads from the Scottish Drift Championship, and we're looking at his setup, and just a standard engine, big turbo, manifold, wastegate, and yeah, he's running about 450 horsepower, and he'd been doing it all year, so no problems there. Obviously with any engine, if you're wanting to run more power, you have to do more to them, but you can pull like a 600, 700 horsepower, and it seems to be effortless for a 2J. and these engines seem to be limited. You can pull 1,000 horsepower out of a standard block, but it kind of destroys them in the end. If it depends what your application you're doing. I would imagine a standard block and a standard oiling system and a drift car wouldn't last long in a drift build. Well, thank you very much for watching. If you like what we're doing, hit the like button, and any questions, comment down below. Check us out on Facebook and Instagram at Pro307, and if you want to continue tumbling down the rabbit hole that is the RB26 build for Pro307, check out our next episode where we're going to be doing the cam timing, degreeing the camshafts. We're going to be speaking about some of the accessories we're going to be using, like the PRP head drain kit and some other bits and bobs just to make the build a bit more professional. And we're also going to talk about the intake side of the... Thanks for watching, catch you next time.